Advanced Algebra 2, 4th and 5th hour. This video is for Monday, 3/23. We're going to have a quick one today. We are going to review our exponential and decay graphs and the three different types of equations that we have to solve. And that's all we're going to look at today. Okay, our first graph here, problem number 1. Remember how we know if it is growth and the graph goes up, or if it's decay and the graph goes down. We look at our base. If that's greater than 1, which this one is, it is growth. If it is a fraction less than 1, greater than 0, it is decay. Also, I want to point out an important part of these are realizing that there are asymptotes, like a half asymptote on each of these. On the growth, it goes to the left. On the decay, it goes to the right. We need to pay attention to where those are and how they have moved. All right, let's run through our steps real quick. If we have anything in our exponent up there by that x, then we need to perform that to the x, the opposite of what it looks. So we would subtract 3 from our x's, get -3 and -2. Anything outside of that exponent, which we have a 4 and a -5, we need to do to the y's. We do the times 4 first, and we do the -5 last. So we'll get -1 and 3 there. So the points we will graph are -3, -1, and -2, 3. Also, we want to pay attention to our asymptote. What will our asymptote do here? Well, it will move left 3 and down 5. Now, where is our asymptote at? Originally, it would sit right here on a growth. So we're going to move that back 3, left 3, and down 5. It's going to be right there. It's important to have that asymptote in the correct spot. Okay. Then we just graph our 2 points that we found, -3, -1, and -2, +3. And our graph will be running uphill down there and hugging the asymptote on the left and heading towards the moon on the right. Okay. Okay, now I want to point out something, how you can visually see that times 4 in that graph. The blue graph is the graph of the base graph of y equals 2x. And notice right in here, we go up 1. Right here, we go up 2. Well, what happened on our graph? From the level of our asymptote here, we went up 4. From the level of our asymptote to that second dot, we went up 8. These have been multiplied by 4. That's where that 4 comes into play, that times 4 out front. Okay? All right, now let's look at our different types of equations, and we have 3 different types of equations. 2 of those have logarithms in it, and it's the difference between having logs everywhere or missing a log somewhere. Okay? That's the difference between when you see logarithms in a equation. We got to handle these differently. All right? If we have logs everywhere, it's pretty straightforward. We simply drop our arguments down and set them equal. Okay? And we get going from there. I'm going to work this and come back. Okay, there is my work. I should have told you to pause it and work it and come back, but we'll get better at this. Now, what we have to remember is our answers just are simply automatically not answers. We have to check these. And if we look at this -4, when we plug it in, on both sides, we get a log base 7 of -4. And remember that your argument can't be negative. Okay? This must be positive. So that means that -4 has to be thrown away. Now, when we plug the 5 in, on both sides, we get log base 7 of 5. And that's a positive number, so 5 is okay. 5 is our only answer. Okay. The second type, whenever we are missing a log, then that means we can do the hook, or you can do the slide method from Mr. Patterson. Okay. My hook would be that right there. Or just slide the 4 over and make your exponent. Okay. And then we'll have to solve what we have. I'm going to I'm going to do that and come back with it worked out so you can pause and do the same. Okay, here is my hook, or my work, and all I did was I did the hook. 4 cubed equals x minus 5. There it is. I solve it and I get 69. Now when I take 69 and plug it back in, I get a 64 right there, which is positive, so we're good to go. 69 is our answer. Okay, so that's and how to do a problem if we have logs everywhere and if we're missing a log. Okay, on to the last type of equation. Our last type of equation is when we have an exponential equation, and remember, we need to have bases that are the same. Sometimes in these you have to change one, sometimes you don't have to change any, other times you may have to change both. We're going to have to change both of these. And I'll get you started here and then you can pause. We can change both of these to some kind of power of 3, and then we would be in shape and ready to go. So pause here, work this one, and then resume play after you have your answer and you can check your work. Okay, here's what I came up with. 27 is 3 cubed. Right here, 27 is 3 cubed. 9 is 3 squared. Now when we have our bases the same, we can simply take our exponents, drop them down, and set them equal. And somehow, some way, remember that you got to distribute on both sides. I wrote this side with parentheses, and I distributed this one as I drop it down and didn't want to rewrite anything here. So we solve and we get 9/5. Okay, now I'm going to show you how you can use your calculator to check that real quick, because the calculator will do this for us. So you give me a second. Okay, if you have a calculator that will let you insert your own exponent, and I worked it like you had a calculator like mine. We take our 9/5, we go back up here and we plug them in. Okay, we can punch into our calculator using the caret button on calculators like mine and just put parentheses around your exponent. Okay, we can do that to both sides of that equation pretty easily, and in both cases we get answers of 38,050.8. So we know that we've done the correct work. Okay, all right, use these notes and move on to your homework, and I'll speak to you later. Bye.